Missing Will and Mike, so we'll wait for them to get back and we'll get started. Enjoy. How's it going? So Jennifer, did you do joins? Whatever. It's not the most basic thing. Yeah. Yes. I'll give you that. Yeah. It can get pretty complicated though. So you're gonna be. Sorry. Nice. So Jennifer is going to be your go-to student resource for this material if you don't understand it. So. Yeah. Well, I mean, it's like half SQL, half how to use SQL in a program, right? So. But yeah, in previous cohorts, it's kind of been hard for people to pick up on a totally separate language when they're still trying to. You think so?
Oh yeah, like children's book.
Really?
Yeah.
Because SQL gets really complicated. Like the SQL, I understand Java about 1,000 times more than I understand like advanced SQL queries. Yeah, I can see that for sure. Yeah. All right, ready to go? Rock on. So we're going to join together today. We're going to learn how that works in a relational database. So joins. So remember we made a game tracker project. I think it was last week, maybe. We made a project to track our games. So if we wanted to create a database to track our games, we might say like, they have a table called games, and game would have an ID, it'd have a name, it'd have a genre, it'd have a release year, and like a username, right? For the user that has the game. So what would happen if we wanted to add some more data to our database here, to our table, like password, for instance? So you have to add a column called password to this table. So this is the only place where you're storing data is the games table. Another column here next to name, genre, release year, and username. It would be maybe user like password or something like that. So imagine if you have another game. So if you think about what's different, like, so say Alice submits another game, for instance. So let's say she submits Final Fantasy VII, right? So ID for Final Fantasy VII would be 2. Name would be Final Fantasy VII. The genre would be RPG. The release year, I think 97. We covered this before in class. And username would be Alice, and the password would be Alice. Right. So the username and password columns have the same data for those games, right? In fact, for anything that Alice submits, the username and the password fields are going to be the same. Like if, say, Alice is a big fan of this website and uses it all the time to submit like hundreds of games, her password is going to be in that same column like 100 times, right? And the username is going to be 100 times there too. So that's kind of strange, right? That should feel kind of weird, because I mean, this is the games table, and we're storing user data inside of it. In order to do that, we have to duplicate the data. One is not just a games table, but like maybe a users table and a games table. The games table would store game data, and the users table would store just user data, right? So the user could expand. Like you could store like not just username, but like first name, last name, password, email address, birthday, whatever. Like last logged in day. If you try to start adding those all to the games table, it would quickly get stupid. It would just be dumb. I've seen databases like that, though, by the way, in professional grade products. There's just data duplication basically everywhere. It's a disaster doing that. So this is more along the lines of kind of what we would like to see in our tables. So the first thing here is the users table. So each user has its own ID, right? Each table typically has its own ID. It's a unique identifier for that row. So no other row in that table is going to have that same ID. Users have a name column, which is a varchar, and a password, which is also a varchar. By the way, Hunter2 there, does anyone recognize that? This password here, Hunter2. It's a reference to a really old school like batch.org conversation. So hold on, never mind. You can look into it later. But basically, someone tricked a guy into thinking that his password was to other people, but not to himself. So like if you type your password into IRC, that's your password to you, but to everyone else it would show up as asterisks. And to prove it, they just typed a bunch of asterisks in, they hit enter. It's funny. Anyway, so we have our user table. We also have our games table. So we see we have, which is distinct to these games. So that's what uniquely identifies the game in the games table. And then we have name, which is the name of the game, the genre of the game. We have RPG, FPS, and RTS. We release year, and we have user ID. Okay. So instead of storing every column about the user in that one big table, right? User data into its own table, right? And no matter what we do to user, we always have the user reference in our games table. It's like
I noticed for user ID, you didn't use the identity.
correct.
So each table only has one identity type.
Usually. It's possible for you to have more, but those are kind of edge cases. If you're referencing the identity of another table, it's like the identity is an integer by default in this database. Sometimes people use other data types for identities, but we won't get into that too much. But yeah, if you're referencing an ID somewhere else, it's an int that you're pointing to. So the identity is kind of it's a special int. It says that this isn't just an int that we're storing, it's an int that is incremented every time we enter a row, and it's what's called the primary key for the given table. I've been avoiding the terminology primary key, but basically the identity establishes what's called a primary key column. So a primary key is like a unique identifier for that row in that table.
So you don't need that identity there. That's just using
Yeah.
the same one.
Mm-hmm. So that would be a foreign key. So what that would be is what you'd have on the games table is a foreign key in that column, the user ID column, to say that in here goes data that we're going to get from the users table. So you can just put 4 into the user ID column. If you establish a foreign key constraint on that games table, that would prevent any integer that's not a valid user int to be in that column. So if you try to like insert into games user ID is 4, it's going to be like error or foreign key constraint violated. Can't do this. Beep boop problem. So that's called referential integrity, by the way. It's basically the usage of primary keys and foreign keys to ensure that your data is valid. A lot of database systems, again, don't enforce referential integrity. And as a result, user IDs can be anything in that column, right? Those are the databases that frequently cause lots of issues, because over a long period of time in the life cycle of your application, tables a lot, and there's a chance that, like, say that there used to be a user with user ID as 4, but they're gone now. But we still have games that reference those. So we're going to have unexpected side effects because of that. Whereas before, if we removed the user with ID equals 4, we could actually delete he had also pretty easily. Okay, so referential integrity is a thing. It's how you architect your tables. That's a thing, by the way. So if you go into a job interview and you mention referential integrity, people's ears will perk up. Be like, oh, this guy actually knows what he's talking about, right? So what we really need to do is as a way to return this data in a way that can be used. One way to do that is to use a SQL query called an inner join. So think of it like we're joining these two tables together. I think of it like I don't know why, I think of it like a zipper, right? We're like zipping up these two tables on this key. So the concept of inner joins is basically like you map the ID column of user with the user ID column of the games table. So it's like it's taking this data here and then like tying it up with its data here. Okay. So we'll see here. It's like select everything from games, inner join users on, inner join users.id equals games.user ID. So this basically shows the system how to map up these two. That we're saying that these rows are basically the same data we're talking about if the user ID is the same as the users.id for this row. It says on users.id equals games.user ID where users.id equals 1. So it's basically going to give us the games that user 1 has with all the user 1 columns. So it'll give us name, password for the game, the genre, and the release year in one result set. Okay. Different things you can do with joins. By far, the most common thing you do is an inner join, but you can kind of think of Venn diagrams. So select from table A. You can name your tables, by the way, in the scope of a query. So that's what that's doing there. It says we're joining table A with table B on A.key equals B.key. So this is like a generic SQL query, like whatever key you have there, right? Simplest inner join syntax and kind of what it represents from a set theory standpoint. So like you have all the things that are in A and B, and inner join is the intersection between those two things. It's possible for B to have things that A doesn't have, right? So you have a left join where you want to get everything from A as well as everything that overlaps A and B, and you accomplish that by that. And a right join here and an outer join basically gives you everything. Far less common, but it's still possible to do all of these in SQL, right? So by far, what we're going to be doing, what we're doing in class is just this first one. It's an inner join. Concern with is mapping data together with other data and you do that with an inner join, right? So let's go back to our form web project and add a database to it. Let's see if I still have it. There we go. Hey, forum web. All right. So we need to add H2 first of all. Spark already. We're going to add H2. Chug. Okay. All right. Perfect. So one thing we're going to do now is kind of write some tests along with the creation of these databases and stuff like that. Feel for how tests might work when we're working with databases. All right. So we're going to write our methods and then immediately write a test for them before we actually use those methods. So in our main class, we're going to write this static. We're going to import this from Java SQL. Okay. So this create tables method is going to operate on a connection. It's capable of throwing a SQL exception. We're going to create a statement, and that statement is going to be the create table does not exist users with an ID, name and password, and messages with an ID, user ID, reply ID, and text. So remember, with the forum thing that we did, every thread that you can, every message you can send could reply to another message, right? So that's storing that same data there. So the next thing we have is insert and select a single user. So let's take a look at that. Their user model. And do the standard getter setter pattern here, just so we, for consistency's sake. We're going to set those fields, and we're going to add a constructor that operates in those three fields. We're also going to add getters and setters for those three fields. So back to main.java. Just make sure we have what we do here. So we need a constructor for a user that takes in just a string. Modifying this just a second anyway, but just for now, so we don't get compile time errors. Okay. So we have create tables, which ensures that these tables exist in our database, right? We have insert user. So for insert user, it's a method that returns a void, which means we don't care about what create user or insert user returns. We just want it to do something, and that something is to add a user, right? So the information that's pertinent that we can give the system about a user is the user's name and their password. So we're going to take these name and password parameters, and we're going to build a prepared statement based off of them. Remember that using variables to run a SQL query, you always need to use a prepared statement. This protects you from SQL injection vulnerabilities, remember. Because if you did a query like this, the statement.execute up here, then you open yourself up to writing special, like usernames, for instance, that hijack your database. So we build a prepare statement here with con.prepare statement. Set string on these question mark positions, like name and password, and then we execute the statement against the database. And effectively, that inserts into users the values null question mark or null name and password, right? So null, keep in mind, that's the ID. Database will give the row that value. So select user. So we want, given a connection, we want to select a user by his name, right? So since we're making a query based off of input, right, based off of a variable, we need to build another prepared statement. So we do con.prepare statement, and the query is select everything from users where the name is question mark. You could do something like this as well. So top 1 star from users where name is question mark gives us 1 row for sure, but only 1 person should have our username. So select star from users where name is question mark. So we're going to replace the question mark with the name that we passed in, and then we're going to execute the query. Users where name is. So while we have beta in our results set, we know cognitively that that's going to be just 1 row. An ID, we get it from getInt, and we pass it the name of the column. The column is ID, which contains the ID data. The password column contains the password data. So string password equals results that get string password. And then once we have the ID, we know the name, and we get the password, we can return a new user object. And down here, if results.next was false, like there were no result sets as a result of our query, then we wouldn't be making a new user. We'd say there's no user with that name, right? So we return null. There's no user that matches that name.
The results that get in the string, those results come from the query of the database.
Yes. Basically, you're going to get a result set object back. So we're calling that results. So result set is like a stream of results. Okay, so next performs 2 functions. It updates the stream to the next result, and it also returns a Boolean whether or not there is something next.
Class, that result set. Is that a class?
Yes, result set is a class. It's in the java.sql package. Pretty complicated class. Pretty well documented though. So effectively what this block of code does is just iterates through all of your results. Actually, this would iterate through all of your results. We know there's only going to be 1 result, so we just put the if. Right? Same basic thing. There's a way to get the first result from our result set. Okay. We have the creation of these tables, we have inserting a user, and we have selecting a user. So now we're going to start running tests. So the way we're going to work with this is we're going to start using JUnit on this project. So one way you can include JUnit in your project is to look it up through the libraries pane. So we'll download and use JUnit. Okay. So we need to make a folder to store all of our tests. That's next. Okay. We go to modules, then sources. Let's see where it says to put it. It says source, under source, put a folder called test. New folder, test. And once we have that folder, we need to mark it as a test folder. So this tells IntelliJ, this is where we're going to store our tests for our current project. Inside this source test folder. Different colors mean different things, right? So the out folder is excluded from the project. Source means this is what we're going to compile, it's our source code. And then inside this, we have a part of our source code is this test folder. So this is a special section in our source that is the test area. So any class that's in here is going to be a test class. No, we were putting at the root, but it's kind of arbitrary. So it says, finally, make sure your main class is open and go to navigate to test and choose to create new test. Alternatively, you can also just click the main class here to alt enter and create test, right? So you navigate the test, create test. Same thing, right? So we're selecting JUnit 4, classes main test. We're going to insert basic tests from our database connection stuff here, right? It's all the database connectivity things. So we're going to write stubbed out methods to test those things, right? Click OK. And we get this main test class here. It's inside the source test folder. It lives here now. And it's here because we marked this as our test folder, right? And these don't test anything yet. So you could technically run these tests, but they'll all pass because we're not doing anything. So that should show you that just because your tests pass doesn't mean your code is right. Okay, because they could be testing nothing. Your test is just as important as understanding your code. Making sure your tests actually test things is an important thing. So helper method, in our main test, we're going to add this method here called start connection. The start connection basically initializes everything. It makes a new connection object. It gets that connection from this JDBC connection string. This class, the simple way to make a connection object was to say get connection on, it looks like this. So by default, the H2 database engine or all the things you do to it in a file somewhere, like with respect to the place that you ran the application. So you may have seen like a .db file, mv.db or something like that in the root of your project. That was generated by H2. So when you stored something in H2, it would save it in the file. If instead of that you have this guy right here, this is a supported connection string by H2 to say an in-memory database and not a file-based database. So every time we restart our app, basically H2 loses all of its information. If it's running, then it gives you all the benefits of using a relational database, like you get joins and stuff like that. Really great way to test your code, because if you want to like create a sample database and then not have it have it just die after you're done running your tests, then really well. It's like, here's a way where you can like test your SQL queries, see that they work, and then just ditch because you don't care about the output. All in one step. So it's pretty cool, right? So let's look at test user. We're going to test the creation or the selection of a user. Well, we're going to look at actually the insertion and selection of a user all at once. Let's do that. So we have connection equals start connection. So start connection is going to give us a connection object and make sure that our tables exist. Keep in mind that these queries say create table if not exist. So it just basically ensures that those tables are there, right? And then once we ensure that they exist, we're going to return the connection object. So then on line 24, we're going to use the main.insert user static method to insert the user with no password. And then we're immediately going to select, we're going to call main.select user. The user we want to select is Alice. Close our connection. After this runs, we know that Alice should be a valid user in the database. After this runs, we know that since Alice is a valid user in the database, that we should retrieve Alice from the database. And then since, for technical reasons, we want to close our connection, there's other ways to approach this, which we'll cover later, but essentially, if you open up a connection, you need to close the connection to a database. Down here that says, we're asserting that it's true that the user is not null. We know that the user can't be null if our code works properly because we inserted a user from the database. Right? So this tests the insertion and the selecting. The selecting, the insertion is it's kind of a, we need more tests to do that itself. So let's just make sure this test passes. Let's get just to ditch these tests for now. It's just what they were generated. Yeah. We got greens. That's good. So H2 started. We inserted a user into the H2 table, and then it succeeded in retrieving that user from the table. All right. So now that we have our user tests complete and we know that we can insert and retrieve users from the database, let's focus on inserting and retrieving messages. Okay? Let's go ahead and copy these guys here into our main class. Now keep in mind that there's no reason particularly that we're putting them in main other than it's just convenience. Usually you would have a class that's like, maybe like data repository or something like that. It would have these static methods in it. So all of your data access is consolidated into that one place, right? But for now, we're just putting them here just because that's our class that we're currently using. Look at the details of these methods. Let's look at the method signatures themselves, right? When we inserted a user message, it returns void. There's no return type. We don't care about what insert message returns to us. We just care about what it does, what the side effect of running this is. We store a message in a table somewhere, right? So what it needs to do its job are a connection object, a reply ID, and the text of a message. Okay? So connection that we're running these statements on, we have the user ID that made the message. We have the reply ID is the message we're replying to, and we have the text of the message itself. Okay, so those are the things that make up a message. Or the current user ID, the message we're replying to, and the text of the message, right? And since we're running I guess our SQL engine, they could all throw SQL exceptions, so we're saying that our methods can throw the SQL exception. So that's insert message. And select message is a method that's static in our main class. It returns a message object. So anything that's a message is going to get returned. So all it needs to do its job is a valid connection and an ID. It's the ID of the message, right? And it too throws a SQL exception because, again, it runs SQL queries against the database. And anything that runs SQL queries against the database can throw the SQL exception. Okay. So let's look at the meat of these. So on line 30 here, we're calling con.prepare statement again. The reason why we're doing that, again, is because we're passing into this statement. So we never want to concatenate strings together to build queries. We want to use this prepare statement syntax here, and we need to replace the question marks with these calls here. So this will replace the first question mark with user ID, second question mark with reply ID, and the third question mark with text. And then it's going to execute. And we have no return statement because the return type of this method is void. Right? Insert message. After this runs, this prepared statement is executed and the message is inserted in the database. Right? So a select message. So again, it's a static message. We went over the method signature before. So we're building a prepared statement again because we're taking data from the parameters here. So this one is we're going to be using an inner join. So we're getting yeah. Okay. So since the message class here doesn't necessarily line up exactly with the data we're storing in the database. So in the database, we're storing an ID for the current user. That we get back stores the name of that user, right? But the name lives in the users table. So we perform an inner join on messages and users. So it says select everything from messages, inner join users on messages.userid equals user ID question mark, or messages.id equals question mark. So if you have a message ID of 4, it's going to get, the end result is going to be one row, but that row is going to have all of your message columns mapped with all the user columns as well. So that's the inner join. Think to yourself, well, you could probably just do this, like select star from messages where ID equals 4, right? That would only give you the message columns, right? That's the data from messages. But in order to populate our object, we need the author, the name of the author, right? So the message object has an ID, a reply ID, name, and text. So this name comes from the users table. So we need to inner join all the user data as well as the message data. Okay? So just like before, we're replacing the question mark in our statement with, we're replacing the first question mark with the ID we passed in, sorry. And then we're executing the query. For our results to parse, we're getting the reply ID from the integer at messages.replyID. We're getting name from users.name. Text is messages.text. And then after we have reply ID, name, and text, we already know the ID of the message, so we can make a new message object. And if there were no results, we return null. We had no messages that matched this ID. Okay. Have code that inserts and selects messages, we can test that insertion and selection of those messages, like so. So we start a new connection. We insert an Alice user. And we're also ensuring that we can select Alice from the table as well. And then we're inserting this hello world message. And what we're inserting there is the user's ID. -1 is the reply ID. Remember, that was the ID that we use when you're not replying to anybody. You're just making a new message. And then here's the text of the message right here. And then immediately after we insert that message in the database, we're testing the selection of that message from the database. So we're going to get the first message on our connection and then close the connection. And since we know that there was one message in there, if we selected one message, it should not be null. And we're going to, in fact, assert that it is not null. So if this passes, we know that we can both insert and select data on user and message. And lo and behold, we can. Hey, Oliver, do we have a team lunch meeting today? No? Okay. Yeah. Okay, just wanted to make sure. All right. So we ran our tests. The test passed. And we have no lingering database anywhere either. So that's pretty cool. Junk data, and now it's gone. It just ran in the context of our tests and then went away, right? So best of both worlds. We get tests and we don't get to have to manage the output of those tests. So the last thing we're going to do here is get the replies to a specific message. Okay, so this one, complicated. We have select star from messages, inner join users on messages.userid equals user ID, where messages.reply ID is question mark. So you can kind of see how this gets complicated pretty quickly, right? It is a mouthful. If you break this down, though, it's not super terrible. So we're selecting everything from messages joined with users on message.userid equals user ID. So this is a statement here. So let's look at this. So select everything from messages interjoined users. Take the data from messages, map it with user data. Okay. The way we're going to map these things together is we're going to say that the row that has a user ID, where that's equal to the user's ID, is how they map an individual row together. So if the user ID row and the ID row for the users map up, that's how we're going to map those things together. Okay? And the rows that we're concerned with are the ones where the reply ID is what we pass in. So the result of this query is going to be all of the messages combined with the associated user IDs. Messages we're responding to a given ID. So if we pass in -1 to this, so where reply ID equals -1, effectively we would get all the messages mapped with all the user data for those messages for all messages that we're not replying to anybody. Okay, these are root level messages. So after we build our prepared statement, we're calling it set int here to replace the question mark with the reply ID, like before. And then while we have results, note that we're using a while loop here instead of an if statement like before, because we're getting multiple results. So for each result we get back from our database, we're going to calculate our ID, or we're going to get our ID rather from the ID column on messages. We're going to get our name from the username. We're going to get the text from the message text, and we're going to build a message object based off those data values, and we're going to add it to our messages array list. We're going to return our messages array list. So that gets us all the messages that were replies to that given ID. So let's write a test for it. It's getting non-trivial at this point. So we make a new connection. For this test, we're inserting two users, Bob and Alice. And then, let's see, we're getting those users as user objects from the database. And then we are inserting messages into the database. So over this connection, we're going to insert Alice, a message from Alice. And then Bob can reply to Alice. This is a reply, and this is another reply. So array list message replies is going to call select replies. So we're going to get all the replies to the first message. So since we inserted 2 here, this length should be 2. So what we're asserting here is that the number of replies to the context message is equal to 2. This array list should be in size 2. So we'll run this. Because we inserted those 2 messages into the table and immediately tested for them.
Okay, well, with that test, if insert user and select user, this one wouldn't function. So could you then eliminate the test for, would you just want to keep it just in case? You know, because 6 months down the road, if something broke here, it would be easier to, so you can figure out if the inserting or selecting user function was messed up, or if it was getting it into the array list.
Yeah, that's a really great question. I think having these tests is like before you run any test, you'd have like a build database with test data function. So you normally wouldn't actually like insert the users just like this. You'd have it. You delegate that to its own test. So the more granular you can get it, the better. It's just in this case, this is the easy way to demonstrate the power of unit tests.
Okay.
Typically, what you would do is, like you said, like there's like a JUnit attribute. I think it's like a before. Is it before? It's common to find that several tests need some of their objects created before they can run. Annotating a public void method with before causes the method to run before the test method. So here's an example. So basically, or a test class here, if there's a before this, and in this case, initialize it to a new array list before it uses it. So what you would put inside this before, where you tied this before notation is a public void method that stands up all of your data. So like that's where you maybe have a connection field here, and then before you can call it like initialize or whatever. It could be like Tom equals driver manager BBC. So like you wouldn't have to duplicate that code a million times.
Okay. And then would you like populate
Yeah.
To eliminate that portion of the test.
Yeah. Yeah. Okay. Great question, man. So yeah, at the end of this test, let's just run and make sure it still runs properly. At the end of this test, we're ensuring that the number of replies we get is equal to the number of replies we inserted just before it. Now that we've written our tests, we ensure that we are inserting and selecting users properly and inserting messages and selecting messages properly. We can now start using those things with confidence in our code because we know they work. So we're going to begin by removing the global users and messages collections. So up here we have in our main class, have users and messages, which we're not using anymore. Not storing our data in memory anymore. Storing in a database. Woo! All right. Right now, I see lots of problems because I use these things all over the place, right? So in main, we're going to start our H2 database. We're going to connect to it, and we're going to first of all create the tables necessary to serve our data. And make sure we include this throw SQL exception line here. Again, we can throw exceptions. Test users and test messages. We need to get rid of this. So when we log in, we need to select user from our database. So we're going to call select user here. And if the user is null, which means there's no user in the database, remember before we had a hash map, I believe, by their username. And in this case, we're just calling select user from our database. So if the user is null, remember that we just created the user. So it's like we're saying, if the user is null, let's just insert that user into the database. So we call insert user, we give it a username of username, and the password's blank, right? Post login page, post login, replace this guy here with this. That moment when you hit Command C twice instead of Command C, Command V. So when you log in, we're going to try and select the user from the database again, and if we get nobody, we're just going to go ahead and make a user for them, and then log them in down here. So when we create a message, correspondingly, we need to get the current user by calling select user. Insert the message at that user ID with this reply ID and that text. So create message down here. Do that. Finally, when we get the messages, we want to display them properly. So when we get the home page, we're going to update this guy. This user ID reply ID here. Replace our model declaration and our threads declaration there. Right there. So on get, what we're doing is we're selecting all the replies, the messages that we're replying to the context reply ID. We're putting in our hash map a messages key with the threads and the username of the current user. The reply ID is the number right here. And then we're returning a new model in view object with M as the model and this as the template. Okay. Let's run this. Test pass. We'll switch our run configuration to main. Run it again. Spark is booted. Your name, Ben, log in. Welcome, Ben, message, pants. Post message, Ben, pants. So here's things that reply to Ben. Nothing so far. Let's add something. We're posting message. Go back to our home page. Reply ID is going to be -1. And then we're going to see things that go to pants, and then things that go to that. None. Just do like May. So May's going to see that Ben said pants. She's going to say, "What are you talking about?" There's the thing that my wife would say to me, and then she could reply here to say like, "Okay, let's do that," something like that. Right? You can see that we have replies to threads, forum statement here, a forum here. Cool. And all of our operations persisted data to our database, and we used our inner joins to retrieve the data from our database as well. Okay. It is 11 o'clock. We've done a lot so far, absorbed a lot of information. This is the meat of lecture today, so I kind of want to go over what the data looks like in the database next and kind of just run some queries to get you guys used to running queries. But for now, let's go ahead and take a break. Let's go ahead and make it a decent break. Let's say it's like come back at 11:15 and we can continue our discussion, okay? Sound good? Right. That's right. Okay.
Request types. I'm not sure how to implement like put, so I get an ID. I just pull the existing one from the database and like update the fields in it.
Yep.
Great. Other than that, I finally just got Angular like working.
Cool.
I smashed my head against the wall and I realized I should probably clear my browser cache and then I found like the an option J
Really?
I was in incognito.
Seems weird.
Yeah.
By the way, there is a checkbox for like when you have the dev console open that it never hits the cache, which is a pretty useful checkbox to check because then you know that if you're debugging, then you're always working against the latest CSS. Weird that you were in incognito mode and it hit that. I would not expect that.
So I've seen the problem, so I switched over. So I thought,
Usually I will open it up. That's what the method I'll take when I want to make sure that I'm viewing the latest version of a web page. Is to view it in incognito mode.
where is it in application?
You're talking about that checkbox I said?
Yeah.
It should be. They've changed this crap around all the time.
Profiles, or no, text profiles in application.
Disable cache. So if you go here to this, settings, disable cache while DevTools is open.
It's in DevTools, it's just like the console. What's that?
Yeah, well, DevTools is like a DOM browser, and it's also the JavaScript console. You can test your code here. Bye. And then here, sources is all the sources. Like if this reference needs CSS or JavaScript, it would show it up here. This timeline will show you the timeline of how long it took for each resource to load, and it'll show you the events like document.ready. If you reload this page, yeah, you can see that it did not take long at all, but it downloaded all of its assets. You can see like the process by which it spent the page.
Yeah.
So it spent 6 milliseconds loading it, and less than 100 milliseconds running scripts. There was no scripts really, and it spent 21 milliseconds rendering it and painting. You can see the steps here. It's pretty cool. And then network shows you all the requests and like the responses and requests here. This is really useful if you want to see how, like what you were sending and what you're getting back. You can kind of see all that stuff here. So this is the preview of what I got back. Well, if we go back to our headers and we have our response headers, we'll review our source for basically the status of the packet, right? This is the packet itself. So the server sends a response header. This is the server called Jetty. The content type is HTML. This code was 200 OK. Right, and then here's the request header. This is what we sent them. And
The fragment of cache is because you enabled that.
sorry, where? Oh,
Under
here.
Yeah.
Yeah, actually, it's because of that setting. Yeah. So profiles is how to profile your JavaScript execution, so you can like analyze like what objects hang around in memory and like how much memory your application takes up. It's kind of an advanced feature. They also added a lot to this application tab. So this will show you all the different storage options you have and what are stored on the current site with these guys. You have, let's see, security. This will show you like the cert data, I guess. This is all new to me. This is like this changes very recently. Audits. You can actually, it'll tell you what you can improve about your current site. So you'll learn a lot about this. So like Google has this tool. If it weren't here, this is basically the same thing. It has this thing called Page Speed Insights. It'll show you kind of like where you can optimize your code. So if I go here, I actually want to log out. So website here, the Apple website, if we go here to Page Speed Insights, we can reload the page and audit on load. So it's loading everything. And I think it's running it just a bunch of different times. Utilization and web page performance, and it's going to give me a list of tips to do when it finishes its audit. So we have confined external JavaScript. It says there are multiple resources served from the same domain. So yeah, we can't do anything about this because these are external lib folders or libs. So like we have this thing called add this, which is like a way for you to easily add a link to like social networking. We also have Stripe. That's our donation thing. But it's basically your browser can only support a maximum number of concurrent connections with the same domain, right? So a lot of people, they use the use content delivery networks as a way to parallelize their requests to different servers. Have like something like maybe 6. This always changes, so it's variable simultaneously to a server. So you can enable gzip compression on these guys. We don't do that for some reason. I'm not sure why. All the images here apparently are missing cache operation, right? So this is like pretty big impact. And then yellow is like minor impact. So 92% of the CSS not used by the current page. It's pretty significant. And then put CSS in the head. Apparently I have a style block in the body somewhere. But yeah, you can kind of see like all the stuff here. It's pretty cool. You'll learn a lot about like the web by running these page speed insights, right? They'll teach you a lot about like optimization and things like that. So a lot of what you'll learn is there. And then ad block is, I think that's ad block extension added to the dev tools. It shows you which ads it has blocked. So yeah, DevTools is definitely one of the best things ever. Chrome wasn't the pioneer on DevTools for a while. There was an add-on or an extension for Firefox called Firebug.
Yeah, I use that.
Yeah, it basically did the same thing. It kind of led the way, and then Chrome has basically taken everything that Firefox did and it has done it better. So it's kind of leashed the users off of Firefox. I think the browser share is now like Chrome's territory now. Share. It's serving almost a third of the websites on the planet. Well, Chrome 51, and then there's other versions of Chrome.
Firefox.
5.3%, yeah, way less than Internet Explorer 11. I think 11 is for Windows 8, Windows 10. So here's Edge. So very few people are actually using Windows 10, I guess. And here's IE8, which for some unknown, ungodly reason is still being used by 5% of websites on the nation, in the world.
Firefox, it's crazy.
Yeah, that's the power of crappy internal corporate networks. Users on their work machines on Windows like XP computers using Windows 8 or IE8. And they have these like legacy applications that like use Java applets that only run on. So Java back in the day, they were trying to be the language of the web. There was you guys remember Flash? Back in the day, it was kind of a toss-up as to what would become the language of the web. It was JavaScript, there was Java, and there was Flash, and then there was Silverlight. Microsoft put their hat into the fight there. So basically, this is a little bit of a history lesson. Roughly 10 years ago, basically was like, listen, these third-party plugins for these browsers, like these Java applets and these Silverlight plugins and these Flash plugins, they're not good for battery life. They're inefficient and they take up a lot of energy, so we're not going to support them anymore. The death knell for all third-party plugins. So Java fell by the wayside, Silverlight fell by the wayside, and Flash fell by the wayside. That was like the final step. So basically, JavaScript took off. It ramped up like a ridiculous amount at that point. It was already gaining momentum in the early 2000s, but then it like cemented itself as the winner of that battle. Now we're dealing with JavaScript today. But Java used to support these things called applets. Browser, like Java runtime stuff. Like the Chrome doesn't even, by default, support running Java in the browser anymore. But it used to be a very big thing. If you wanted interactivity in your website, you could have a Java applet run Java in your browser. But it's kind of a relic of another time. Let me get some coffee real quick. So notice everyone being kind of quiet today about Hunter. Is like getting it, or is totally off and know what to do, or combination of the two somehow. You didn't sleep last night? Why the hell not, Bill? That's what bit.
6:30. By that time.
So is that someone going to help you find a job after you graduate? Because if not, you need to turn that laptop off and go to sleep.
Well, I'm good.
Did you?
Lecture, yeah.
Uh-huh.
Like closely.
Yeah, I saw you fall asleep. You were asleep for like 10 minutes.
That was when Mike asked the question. Mike asked the question, I was like, all right. I can't resist anymore.
I can tune Mike out for a while.
I'm surprised that my actual brain being
Yeah, I get it. No, I've been exactly in your shoes right now, except for it was video games and not talking to people. Back when I was a fresh sophomore at Clemson, and I had been, I had been waiting for that game to come out for a long, long time. That team that made Portal made a game called Narbacular Drop before they were hired by Valve to make Portal. And so I played Narbacular Drop over and over and over again. It was a short proof of concept game. And then Steam, because the Portal was released at midnight in California, right? So 3 a.m. It wasn't a very long game. It was a 4-hour game.
Yeah.
I opened it up as soon as it was decrypted on my hard drive at 3 a.m. and then I finished it around 7 o'clock in the morning. And you play the first Portal?
Yeah, I played both of them.
So that, like, the game just totally, it's one of the best gaming experiences I've ever had. And the end was just that the cake is a lie song. Like, this is a triumph. I remember just sitting back and being like, that was amazing. Like, so totally worth it.
Yeah.
I think I had class in a couple hours after that. So
I did that all the time. I could be like a midnight release. I'm like,
I remember when Halo 3 was released in high school, like literally like 2/3 of the class was out that day. Like no one was there at all. Oh, everyone's sick today. Weird. It's crazy.
it's like, I remember, yeah, that was like a Call of Duty Black Ops. And that one came out like nobody to school.
Yeah. Anyways, moral of the story. I'll say it too late. But sleep is important.
I'm gonna get a lot of sleep tonight.
That's good.
I'm not going to get out of it. Gym at like 10 o'clock. And I can get home at like 11:30. So.
That's a long day, son. Like, have to come to class and getting home at midnight or whatever. That's a beefy day.
I'm not.
Yeah.
I'm used to sleeping a lot anyways.
Right.
I've been playing like Rocket League pretty much. That's like what I'm doing.
I haven't played that in a while. It's good though. All right. So, welcome back. It's 11:15. Let's get back to work. So, how are things feeling? You guys familiar with SQL? Are you confident that you can like write your own SQL queries yet? Okay. I'm still running that database from my web app here. So it's in memory. We have two tables here. We have messages, which has ID, user ID, reply ID, and text. So let's just look at it. So we have user ID is 1 and 2. This is me. This is May, right? So if I select star, by the way, you can do this. Run 2 queries side by side. Well, you have to put semicolon. Okay. So you can see the results of both right there. So if I select star for messages, and you have ID and user ID and reply ID and text, and you have select star from users, which results in me and my wife.
So you could test your query here,
Yeah.
right?
No, absolutely.
You could put what you're going to write in Java in there and see what happens. Perfect.
Yeah. Most of the time, if I'm like trying to test a SQL query, it's not in Java. It's in a console very similar to this. Yeah. So say that I want to return one result set. So this is the same as two, like this is 2 result sets here. Like in Java, in the Java world, we're going to execute a query and then we're going to get a result set back. So we get a result set with 4 results in this query and then 2 results in this query, right? But we want one result set back, which contains enough information to populate our message object. And remember, the thing that we need from to get the username, right? So we're going to write our inner join to take care of this. Select star for messages, inner join users on messages.user ID equals user.id. Users.id. Okay. So these are the columns from message right here, ID, user ID, reply ID, and text. And here's all the columns from user, which is name, ID, name, and password, right? So if I want to see all the threads that or at the roots, I'd say where the messages.id is -1. So here's all the people and the messages that responded at the root level. These are all the root level threads.
Those segments in the table, is it like automatic sort?
Yeah, it sorts your result set, which is just a UI thing. It doesn't change it. You can do ascending and descending order by statements in SQL, but this isn't doing that. This is just displaying it differently. So if we do this inner join here, though, we can see that we get a lot of columns in our result set that we don't really need. And we're not really concerned with the user's password, and we're not really concerned with the column anymore because we already have the username. And so we can actually hone this down, this query, right? So this star is really what tells us, it tells the query to give us all the columns. But if I could tell it specifically which columns to give me also. So I could be like, select messages.id, messages.text, name for messages inner join users. So you can craft your response back. So the result set would be ID, text, and name, which is really the only thing you need to build a message, right? You see how that works? Separate your column names instead of just having a star there. So we're selecting the columns messages.id, messages.text, users.name from the messages table, interjoined with the users table. And how we're joining these things together is we're mapping the user ID with the users.id column. And then we're selecting where the reply ID is -1. This where clause, we can actually just run this, and this gives us all the users with their text and all the authors of those messages. To me, this is where the coolness of SQL comes into play, because you can craft exactly the data that you need with the SQL queries. If you get good at it, then there is a profession, not necessarily web development or Java engineering at all, but database administrator. If you enjoy SQL, then there's a lot of money in it. If you get good at SQL, you're highly valuable. Just like Java. If you're good at Java, you're highly valuable too. But DBAs are in short demand. So is this making more sense now? You can see that SQL is more powerful than just selecting everything from a database or everything from a table. You don't just have to accept that those rows are going to come back like that. You can hone your data down to what you're talking about. So I want to talk a little bit about what we saw before when we first were starting to talk about the need for multiple tables. What you're storing in a database is, a database contains many tables, right? So this one database is this /main database. It has a messages table and a users table, right? So for each distinct object, I mean, you could think of them as they're called entities, right? You probably, in most cases, want a table to store those entities. All right, you don't want to mix those entities together. So you have to think to yourself, like, where should this data belong? Because before, like when we first approached this problem, we were like, well, we could just put the author name in the messages table and call it a day. We realized that every time we added a message, we were duplicating that name, right? And if we continue that pattern of just putting columns in that messages table, then soon we would have just a stupid amount of duplication going on. So the solution was to split it out into 2 different tables. That's actually a term. There's a programming term for that. It's normalization. So when you normalize your database tables, you split them into distinct that minimizes duplication. So if they're all squished together, like in that one messages table, that's a denormalized database, and that's bad.
Wait, can you repeat what you just said?
Sure. Do you recall in the beginning of this discussion how we stored the author's information in the messages table? We just had the author name. We were like, screw it, they can just go there. Technically, that author data shouldn't have belonged in the messages table. If we tried to put it there, if we added a new message, it would duplicate all the user data. So we'd have like game 1, Alice's password. Game 2, Alice's password. Game 3, Alice's password, so on and so forth. And that data, Alice's password, like you'd have to, like if you wanted to update a record, for instance, or say you wanted to update Alice's name to, to change her name to Anne or something like that.
She had like 1,000.
Yeah, you have to update every record. If you change your password, it's just like update the messages table where the name is Alice. Even worse, let's see. What if you had like 2 Alices that wanted to sign up for your website. How would you change one of their names to something else meaningfully? You can't. It's how would you even tell who was who? You had to the only thing you could do is hash the password. You had to take in the password and be like, give me all the users where their password is this and their username is Alice. And then update all of those users, their names in the games table. You don't want to be in the business of doing that kind of stuff because I guarantee you, and in practice, this is what I've seen all over the place, is that your data will turn into a big pile of just nothingness, and it'll be hard to deal with, and no one will want to touch it ever.
Yeah, it's also just like kind of like the readability type of thing.
Yeah.
You drop a code like you want it to be.
Yes, yes. Separation of concerns. That's a huge deal in programming. Is that like these tables should be responsible for their data and nothing else. Methods should be responsible for performing one action and nothing else. Or data about one object and nothing else, right? I mean, that's a general theme that you'll see recurring in programming is single responsibility. So don't repeat yourself. Dry. That's a big thing in programming. If you find yourself copying and pasting code between methods, you need to rethink about why you're doing that. Candidate for refactoring it into its own method, right? If you find yourself having to repeat the same snippet, be like, well, could this actually be just a method call to some methods? And just call the method instead of copying that same snippet. Is the lack of referential integrity that comes with a denormalized database. If you don't have referential integrity, then people can abuse your system. In fact, story time again, and a previous employer, and I won't name names because there was a piece of proprietary software that limited you to like 1,000 uses per. But basically, that software was hosted entirely on their servers, like on company servers. So they had complete control over the data. So one of the developers noticed that there was no referential integrity on the count of used table. So he just monthly would just clear out that table. And then the app was like, okie dokie, keep running. I don't care, because it had no referential integrity. So we'll talk more about primary keys and foreign keys. But for now, this is a good first step into SQL. Cool? All right, let me think for a second about what I want to cover today on SQL. So yesterday we covered the basics of SQL, like how to make a connection. Today we made our queries a little bit more advanced by introducing a SQL feature called inner joins. We talked about normalization. So I don't know if you guys have noticed, but I like to point out when like show up like in class. So like if something shows up in class that is or you will hear about in your everyday work. I like to point it out so you could like maybe write it down and maybe research later. When a database is in a good place organizationally and it's normalized, it's called third normal form. That's how you normalize a database. It's called third normal. It's a mathematical concept, whereas you're reducing duplication in your database to as little as possible. In this database, with the authoring data, you just have a foreign key to the user ID. So yeah, there's that. And that is basically what I wanted to cover today. So we're short by a little bit. I'm going to take a second to update the assignment for today. Good to go. Are there any questions?
What really totally gonna depend on
This is kind of baseline SQL. If you say you know SQL, you should be prepared to insert, update, delete, also write an inner join. Baseline. It kind of starts here and gets. Yeah,
Let's
gets
see
really
how it
complex.
can get that much more complicated. Prove me wrong, but just like what I've seen of SQL. Just tables and rows.
Okay, well, when you're dealing with like multiple inner joins, multiple result sets, it can get quite complicated as to what you're actually reasoning about, or if like you're using a cursor to iterate over specific result sets in SQL, it's pretty complicated. Whole concept of SQL, like when you run a SQL query, before the SQL engine actually runs your query, it builds what's called an execution strategy for your SQL query, and it shows you like different the steps it's going to take when it retrieves your data. So like some steps you'll take will require a full table scan. Will require a full table scan most of the time. So optimizing your SQL queries so that they don't take forever is very important because they're already hitting an overhead of hitting that resource. So you're making a request, the database is getting data back, that's already more time round trip than you want to spend at all. So not spending a lot of time on the database is super important. So optimizing your SQL queries. So it's also, you'd be surprised, like the data we've retrieved so far is pretty simplistic. It's like give me these things combined together. I'm trying to think of a case off the top of my head where it doesn't fit that model exactly, so it gets very complicated. Like if you want to, start getting like the distinct entities where they, like you want to group them by some column value and get the distinct ones and order them ascending, joining on multiple column values. Like, and you're using like aggregate functions, like summing the totals together. Like if you want to get the total score for a user across all of his high scores for his games or something like that, and you order that like descending, like, it can get pretty complicated as well. So like this is easy, yes, and it's like adding more tables to this just seems like adding more entries to the inner join query. But there are a lot of queries out there that don't exactly follow this inner join model that require a lot of tweakery. Yeah. But yeah, I think if you come at it with the right mindset, like this, then I think you're actually a step ahead. So, like I wish I had, yeah, tweakery, hackery. So I kind of had to do all of this like by trial and error. So it would have been nice to have done this like this. Someone could tell me this and not have me like figure it out. Anywho's.
Question for you.
Okay. Hopefully I have an Angular answer for you. If not, we can consult Luke.
I mean, in a nutshell, it's like everything I want to happen is happening, but it's like jQuery, you do like the Ajax call and you do like on success, do this, like reload the page.
Mm-hmm.
Operations are happening, but the page is reloading before the changes have taken place, so I have like refresh.
It's like think I know what's happening. Or is your reload line of the Ajax request line?
Yeah.
So the Ajax request, you need to, we'll talk about it in a second. Cool, guys. Well, that's all I have for the lecture today. Material, so I kind of was expecting like tons of confusion around it, but it seems like you guys are handling it okay. We'll kind of see, I guess, on the homework assignments how they pan out. But cool, rock on. Well, I'm gonna go get to work on the assignment, and I'll let you guys know when it's posted. Bye, wife. I love you.